Hello everyone, in this video we are going to learn about gradient and the derivative of curves. Firstly, let's quickly recap what is a gradient of a straight line drawing 2 points. That is m equals to y2 minus y1 over x2 minus x1. Well, for the curve, the gradient is constantly changing. So if we want to find the gradient of a curve at a given point, we can find the gradient of the tangent to the curve at that point. So for this point, it means that the tangent just touches the curve at this point. Let's see some example question. So the diagram shows a curve with the equation y equals to x squared, that is a green one, and the tangent t to the curve at the point A with the coordinates 1, 1 is shown. So we find that the point A is 1, 1. Now for part A, it asks you to calculate the gradient of the tangent t. In the diagram, you see there is another point lays on the tangent, that is point B, with the coordinate 2, 3. So we can find the gradient of this straight line by using the formula that m equals to y2 minus y1 over x2 minus x1. That equals to 3. So the y coordinates of B, so 3 minus 1 over 2 minus 1. That equals to 2. So the gradient of the tangent t is 2, which also means that it's a gradient of the curve at point A. Now let's move on to see that part B said that question A is jointed to point P by the chord AP. Calculate the gradient of the chord AP when P has the following coordinates. So for the first one, we know that the point A has the coordinates 1, 1. So same, we use the formula that m equals to y2 minus y1 over x2 minus x1. That equals to 2 minus 1 over, that should be 4 minus 1. 4 minus 1 over 2 minus 1. That equals to 3. For part 2, we have m equals to 2.25 minus 1 over 1.5 minus 1 equals to 2.5. For part 3, we have m equals to 1.21 minus 1 over 1.1 minus 1 equals to 2.1. And for part 4, we have m equals to 1.0201 minus 1 over 1.01 minus 1 equals to 2.01. So we have the gradient of the chord AP. Well, as you can see, P, here's the coordinates P, so P gets closer to the point A, that is 1, 1, get closer to that. And the gradient of the chord AP also gets closer to the gradient of the curve at A. That is 2. So we can use this approach to find the gradient of the curve at any given point. Now let me formalize this approach. So we have the function that y equals to fx, and we have the point A with the coordinates, let's say, x0, f, x0. And another point, B, we say that x0 plus h and f x0 plus h. Then let's link these 2 points by a straight line. So we have the chord AB. We find that the vertical distance from A to B is f0 plus h minus fx0. Well, for the horizontal distance, that is x0 plus h minus x0 equals to h. So we can write down the gradient of AB equals to f x0 plus h minus fx0 over h. Well, from previous question, we know that as point B gets closer to the point A, the gradient of AB get closer to the gradient of the tangent to the curve at point A, which means h tends to 0. So we can limit this expression as h tends to 0. Thus, we get a gradient function that is dy over dx. So the derivative of the fx equals to the limitation h tends to 0 of the expression fx plus h minus fx over h. This is used to find the gradient of the curve at any value of x. It also named as a differentiating from first principles. So how do we use this expression to solve the questions? Let us see some examples. So for the question 1, the point A with the coordinates 3, 9 lies on the curve with the equation y equals to x squared. At point A, the curve has a gradient j. Part A asks you to show that j equals to limit h tends to 0, 6 plus h. Firstly, let us write down the gradient function. So j equals to lim h tends to 0, fx plus h minus fx over h. The point we know that is a point A with the coordinates 3, 9. So we have that x equals to 3. Thus we get lim h tends to 0, f3 plus h minus f3 over h. So this is expression of the gradient of the tangent at point A. We find that if we substitute 3 plus h into the equation y equals to x squared, we can write down that f3 plus h equals to 3 plus h squared. Same for the f3 equals to 3 squared. So we have g equals to lim h tends to 0, 3 plus h squared minus 3 squared over h. We rearrange that, we have lim h tends to 0, 9 plus 6h plus h squared minus 9 over h. So we have lim h tends to 0, 6 plus h. So we see that minus 9 disappear and divided by h, so there's only 1, so that is 6 plus h. So we get the answer of that. Now for part B, it asks you to deduce the value of g, which means that you just ignore the h. Since h tends to 0, so let h becomes to 0, what we have, write down that j equals to 6 as h tends to 0. So the gradient, of the curve at point A is 6. Now let us see question 2. It said to prove from first principles that the derivative of 2x cubed is 6x squared. So we have the function that fx equals to 2x cubed. To find the derivative of that, from the first principle, we use that the gradient function, that lim h tends to 0, fx plus h minus fx over h. For the fx plus h, which means that you substitute x plus h into the function. So we have lim h tends to 0, that is 2 times x plus h cubed minus 2x cubed over h. And we expand the bracket, we have lim h tends to 0, 2 times x cubed plus 3x squared h plus 3xh squared plus h cubed minus 2x cubed over h. And let us see, it equals to lim h tends to 0, 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 2x cubed over h. And then we can see that we cancel the 2x cubed. So we left lim h tends to 0, 6x squared h plus 6xh squared plus 2h cubed over h. And then we cancel the h. We have lim h tends to 0, 6x squared plus 6xh plus 2h squared. Now to find the derivative of that, which means as h tends to 0, 6xh tends to 0. and 2h squared tends to 0. So we have the derivative of fx equals to 6x squared as h tends to 0. So you can see that tends to 0, here is 0, here's 0. So we only left 6x squared. So that we get the answer of that and done the proof. From this lesson, you need to remember this expression. And now how to use it to solve the questions and do the proof. Well, here is the end of the video. Thank you for watching.